Now the body is in motion. It is going uniformly. But suddenly its speed increases, due to which the motion becomes non-uniform. So what is this change in speed? That change in speed is termed as acceleration. So acceleration is defined as rate in change of velocity. Now whenever you hear the word rate, it is in respect to time. Whenever we say that there is a rate of change in physics, it is related to time. So acceleration is rate of change of velocity. So it could be written as velocity upon time. Now we see that a body may perform even non-uniform motion. So due to which the starting velocity and the ending velocity may be different. So we need to write a mathematical equation to calculate it. So acceleration is denoted by small a. So small a, that is acceleration, is equal to initial minus final velocity upon time. So initial velocity is denoted by small u, while final velocity is denoted by small v upon time is denoted by t. So therefore we get the equation a is equal to u minus v upon t. This is a very important equation which is not only useful in this chapter but many other chapters of physics. So acceleration is rate of change of velocity and its formula is a is equal to v minus u upon t. So there are mainly three types of acceleration: positive acceleration, negative acceleration and zero acceleration. Now let's see what it is. We know that small u is the initial velocity. If the initial velocity is smaller than the final velocity, it is called as positive acceleration. But if the final velocity is greater than the initial velocity, it is called as negative acceleration. However, if the final velocity is equal to the initial velocity, it is called as zero acceleration. So these are mainly three kinds of acceleration. Now further in textbook, you have graphs. Graph with respect to distance, time and velocity. You just need to remember one thing. Whenever it is a uniform motion, we know that equal distance is covered in equal time. So mostly 100% the uniform motion graph will come in a straight line. All graphs may be curved lines, slanting lines, but the uniform motion graph has to be in a straight line. Now, we have a new concept, balanced force and unbalanced force. As a child, we all have played the game of tug of war. In Marathi, we call it Rashikets. So, in the game, there is a rope, and this is a central point. Here, certain number of people are pulling the rope, and here, certain number of people are pulling the rope. So, whichever teams pulls and bring the team to the other side of the center point wins. Now, there may be two conditions in it, which are fixed. Either both the teams are applying equal force or one team is applying more force than the other. That team wins. So that is the law of balanced and unbalanced force. When on both the side, both the teams are applying equal pressure, that condition is called as balanced force. In that condition, balanced. Both sides are balanced, due to which no one wins. That is called balanced force. While unbalanced force is in which one team applies more force and pulls the other team on the other side and wins. So the condition in which on one side there is more force and the other side is pulled towards it to equalize the force, that condition is called as unbalanced force. So based on it, we have a first law of Newton. So the statement is, a body will continue in the state of rest or in a uniform motion in a straight line unless any external unbalanced force acts on it. What does it mean? Now, Here I have a body. For example, this pen. This pen is in my hand. Did I do anything? Did I apply any force? It is in a movement of rest. But as soon as I apply an external unbalanced force, the pen falls down. That is the first law of Newton. The unbalanced force which I just applied on the pen made the direction and the speed of the pen change. It changed the original position. So this phenomena, due to which the body also changed its direction and speed, is called as inertia. Due to this phenomena, the first law of Newton is also called as law of inertia. So let's summarize everything. The first law of Newton is called as law of inertia. According to the law, a body will continue in the state of rest or in a straight line in a uniform motion unless any external unbalanced force acts on it. So before starting the second law, we need to get acquainted with one more concept, momentum. So to explain the content, I have taken two balls. Here we have a spongy smiley ball and here we have a crazy ball. Now if I throw both this ball at the same time, which ball will go farther and which ball will remain back? So after practically conducting, even you can tell it, this crazy ball will cover more distance than this spongy ball. What may be the reason? Yes, the mass of the ball. You can see this ball is bigger in size. However, it is more lighter in weight compared to this smaller ball. So from this, we understand that the mass of these bodies affect the velocity. This is the phenomena of momentum. So we know that momentum is affected by mass, which affects the velocity. So what is the relation? So the relation is of product. Momentum is the product of mass of the body with the velocity with which we throw the body. Momentum is a product of mass and velocity of the body, and it is applied to each and every object in this world. Now, as we know the momentum, let us study the second law of Newton. This law is also termed as law of momentum. We will understand why when we study the statement. The statement says the rate of change of momentum is directly proportional to the force applied, and the change of momentum will be in the direction of the force. Now, a body will change its original place, will be displaced only when we apply force, isn't it? So, when we apply force, the initial and the final momentum will be different. So, how we will find it? So, the initial momentum. Now we know the formula of momentum, mass into velocity. We also know what initial velocity is. We denote it by small u. So initial momentum will be m, which denotes mass, into small u. This becomes the equation number 1. Now the final momentum will be denoted by mass into final velocity v. This becomes equation number 2. Now, what is the statement? What is the second law? Rate of change of momentum. So, change of momentum will be founded how? The difference between the initial and the final velocity is the change. So, how we will get the total momentum? By subtracting it, and what we have to find the rate. So before also I have said that rate means division by time. Time is denoted by t. So the initial velocity is mu minus the final velocity is mv. So rate of change of momentum is the difference between initial and final velocity, and we are finding its rate, means dividing it by t. So here we find m is common. So taking m common out, we get u minus v the whole upon t. But if we take this part, do you remember any other equation like this we have seen before? Correct. This is the equation of acceleration. So what we will do? We will convert this into acceleration. So what we will get? M into A. So we find that momentum is M into A. But what the law says, it is directly proportional to the force applied. So the force is denoted by a capital F. So what the law says, the rate of change of momentum we have found MA is directly proportional to the force applied. So to remove this proportionality sign, we put the proportionality constant K. Therefore, F is equal to K MA. However, when the body performs a uniform motion, K is 1. So 1 multiplied by anything is the number or the unit itself. So we get F is equal to MA. So here is our main equation. So this equation proves the law. What does the law say? You can remember by it. The rate of change of momentum is directly proportional to the force applied. And force is a vector quantity. As we know, vector quantity has magnitude as well as direction into consideration. So in whatever direction the force will be applied, the momentum will be in the same direction. So this is the second law of Newton, which is also known as law of momentum. Now we have the third and the final law of Newton, Newton's third law of motion. This is a very simple and easy law. We see this is the ball. If I throw the ball is bounced back. So from this we understand that when we make a movement, there is a reaction, whether it be opposite, the ball bounced back, or maybe if there was a window, it could go outside of it. So this is a Newton's third law of motion. To every action, to every force applied, there is an equal and opposite force which acts simultaneously. So now we have covered the three laws of Newton. This is one of the most asked questions in the exams as well.